I'm going to start off with a quick joke because jokes are good, they're funny. What or why didn't the two fours eat dinner? Because they already ate. uh, 4 plus 4 is 8. Good times. The reason I started off with a number joke is because we're going to do a lot with numbers and calculating percentages of things. In chemistry, sometimes when scientists mix things together, they try to determine how much of something actually reacted. We just got done discussing limiting reactant problems, and now we're going to discuss percent composition. There are a few definitions we need to talk about first: actual yield, theoretical yield, and percentage yield. The actual yield when a scientist mixes together a bunch of chemicals is the measured amount obtained from the chemical reaction. That's usually stated in the problem. The second type we're going to look at is theoretical yield. The theoretical yield of a problem is the maximum amount of product produced from a given amount of reactant. So if everything was consumed, if you had everything mixed together and produced products, that would give you the theoretical yield. This is usually solved by a gram to gram conversion, and we'll see this in the examples that I'm going to go over. The percent yield or percentage yield, this is a ratio. It's a ratio of actual yield to theoretical yield multiplied by 100. So for a simple example, say our actual yield of product was 60 grams, but the maximum theoretical yield was 100. 60 divided by 100 would be 0.60, and then multiply it by 100, we'd have 60%. So 60% would be the percent yield for that one. And that's just a simple example. In this slideshow, I'm going to go over 5 examples with you. There's also an example in the textbook that you can follow along with, but the first 3 examples are of the same exact type. The first 3 examples, the question is, what is the percentage yield? Meaning, if we're mixing all these chemicals together, we know we're not going to get 100% because we have a limited reactant and we have an excess reactant. So if we're not going to get 100%, what percent do we get? How much of our product can we actually get when we mix these chemicals together? That's what we're going to calculate. The first thing you do in every problem is make sure it's a balanced chemical equation, and this one is. The equation is percent yield equals actual yield divided by theoretical yield times 100. And the only reason you multiply it by 100 is so that you can turn it into a percent. Now that we have a balanced chemical equation, we need to start off by writing down what the given value is of the problem. If we skim through this problem, there's only one number, 36.8. Actually, there's two, 38.8. But the first number, the one that talks about how much reacts, that is our given, 36.8 grams of C6H6. So that's the given in the problem. The unknown is the percentage yield of C6H5Cl. So they give us an actual yield. If we do a gram to gram conversion, we can find the theoretical yield. Because what we would do is we would say, if we were able to get every last bit of the 36.8 grams of C6H6 to react, what's the maximum amount of product that could be formed? And if you remember, a gram to gram ratio is 3 steps: molar mass, mole ratio, molar mass. Every percent yield problem will involve these 3 steps: mm, mr, mm. So the first thing we do for the molar mass is we put on bottom what we want to cancel. I know some people always ask, well, where'd the 78.12 come from? Don't forget that when you're canceling things out with molar masses, that is the combined mass of C6H6. The mole ratio in the balanced chemical equation is a 1-to-1 because we want to cancel C6H6 and we want to switch it over to the unknown of the problem, which is C6H5Cl. But we don't want moles. We're trying to find grams. So that's why we multiply by the molar mass again. And when we cancel things out, multiply across the top and divide by the bottom. And the theoretical yield is 53.0 grams of C6H5Cl. If you're struggling with this part, go back and watch the videos I recorded of gram to gram conversions. Right, so gram to gram conversions is the first step of when you're doing percent yield problems. So now that we know the theoretical yield, we can plug it into the equation below. Percent yield equals the actual yield, which in the problem it says the actual yield is 38.8 grams, divided by the theoretical yield, which we calculated to be 53.0 grams, multiplied by 100, gives us a percentage yield of 73.2%. So when we mix these two together, we're only going to get 73.2%. We'll have 26.8% not reacting. So that's the first example. Remember, the first three are going to be exactly the same. So if this one doesn't quite make sense yet, don't feel frustrated. It's only the first example. If we look at the second example, it says, what's the percentage yield of CH3OH? Again, we're trying to find the percentage yield. We make sure it's a balanced chemical equation, which this one is. Our equation is the same. Percent yield is actual yield divided by theoretical yield times 100. And you write down what you're given. We're given 75 grams of CO. We need to do a mole to mole, or not mole to mole, sorry, a gram to gram conversion from the given to the unknown. Gram to gram is 3 steps. Molar mass, molar ratio, molar mass. So we do grams of CO to moles of CO. We do moles of CO to moles of CH3OH. And we do moles of CH3OH to grams of CH3OH. When we do our math, we get 85.8 grams of CH3OH. That's our theoretical yield. And that's the number that we end up putting into the percent yield problem. Percent yield is actual over theoretical. The actual in the problem, it says it's 68.4. The theoretical is 85.8. We calculated that. Multiply by 100 and 79.7. So percentage yield is just actual divided by theoretical, and then multiply by 100 to get the percentage. The important part is doing the gram to gram conversion. Grams of the known to grams of the unknown. All right, let's look at the third example. Remember, the first three, there's 5 examples total, so we're almost half done. So the third one is the same type. It says, what is the percentage yield? Percentage yield problems are all done the same way. When we look, this is a balanced chemical equation. There's the equation. We start off with 2 times 10 to the third grams of CaCO3, which is calcium carbonate. That's given. It's a 3-step gram to gram conversion. So we do grams of calcium carbonate to moles of calcium carbonate, moles of calcium carbonate to moles of calcium oxide, and then we don't want moles for our answer, we want grams. So we multiply by the molar mass. When we calculate all that out, we get 1.12 times 10 to the third grams of calcium oxide. I would also accept 1,120 grams or 1.12 kilograms. Those are all equivalent. They mean the same thing. So now we take the theoretical yield and we plug it into this equation. Actual yield is what the problem tells us. The theoretical yield is what we calculated. We multiply by 100 and we get the percentage yield of 93.7%. So those 3 are all the same type where you calculate percent yield. The last two examples are slightly different, and you're only going to see one of these two types. So you're either going to see a simple what is the percent yield, or you're going to see one that looks like this, where they want you to figure out what is the actual yield. And this one in the end, it says what mass of copper is produced. So that would be the actual yield. They give us the percent yield of 56.6%. There's not a lot different with these problems. One thing I noticed though right away when I look at the balanced chemical equation, it says unbalanced. So we actually have to do that on our own. I did it ahead of time and I end up getting coefficients of 2, 3, 1, 3. But just recognize that sometimes it's not a balanced equation. So we start off with the same formula, percent yield, and I just shortened it so I have room here, but percent yield equals actual yield divided by theoretical yield times 100. Now hopefully by now, being in a chemistry course, your math skills are sufficient enough to rearrange a formula. We want to solve for actual yield, and right now it's in the numerator. So what we have to do is multiply both sides by the theoretical yield so that we can cancel it from the denominator, and then we have to divide both sides by 100. So when we rearrange the formula, it looks like this. The actual yield is percent yield times theoretical yield divided by 100. If you need help isolating variables in an equation, come see me. I'll show you your math teacher. So I'm going to make the other one disappear. Gone. We don't need that anymore. Now, once you rearrange that, you're going to solve this pretty much the exact same way as you did before. We write down what we're given. We were given 1.85 grams of aluminum. Boom, boom, boom. It's a 3-step process to go from grams of the given to grams of the unknown. The unknown is mass of copper, Cu. So I do these steps just like I did before. I use the 3:2 mole ratio, and that's why it's important to balance this equation correctly. Otherwise, you would have did 1:1, and that's not going to be correct. And then you multiply by the molar mass, and you get a theoretical yield of 6.54 grams of copper. So that's your theoretical yield. So we calculated the theoretical yield the exact same way in the other problems as well. But now what we do with our rearranged formula, we take actual yield equals percent yield times theoretical, which is 56.6 times 6.54. We divide it by 100, and we get 3.70 grams of copper. That is our actual yield. Now, one thing you can do, and I'm sure your math skills are good enough for this, is you can plug that number into the other equation, the original equation, and work backwards. If you plug in the actual and theoretical yield that you got, you should get 56.6%, and that's the way you can double check your work. So that's the fourth example. We have one more to go over. Oh, awesome. This one's a balanced equation. All right. So this one is balanced for us. We have percent yield is actual over theoretical. This one also wants to know what the actual yield is. So we rearrange the formula. I'm going to get rid of the other one. I start off with what I'm given, which is 1,250 grams of carbon. I do the 3-step conversion, that's gram to gram. I cancel carbon. I switch it to CH4 using the mole ratio. And then I cancel the moles of CH4 to get grams of CH4. And those numbers I got from the periodic table looking at the molar masses. The theoretical yield is 835 grams of methane, CH4. Now we can plug that into our equation. Actual yield is percent yield, which the problem tells us is 85%, times 835 grams divided by 100 gives us our actual yield of 710 grams of CH4. and we can plug it in to work backwards to try to get it all figured out to see if our work is correct. Right? And that's it. That's all we got. So hopefully that helps you to understand it a little bit and it makes sense. If it doesn't, we'll continue to work on it. Flip through your book and look at some examples. And as always, come see me or ask a classmate if you need any extra help. And that's all I got. Thank you for 100% of your attention. Get it? 100%. And time. Have a good one.